Welcome to our poster. Our team consists of Brian Sandifer and Amanda Byrne, who are part of the Mechanical Engineering Department, Sarah Lucier and Tuong Van, who are part of the Mechanical Engineering Technology Department, and Blake Santiago, who is part of the Electrical Engineering Department. We have worked alongside Ward Vessel and Exchanger this past year, designing and prototyping a robust industrial-grade machine to bevel strips of stainless steel in preparation for forming and welding. Ward's current process for beveling material is with handheld grinders and 2 employees. This is dangerous, time-consuming, labor-intensive, and inconsistent. To encompass all of the project specifications, we have made a machine that remains mobile when not in use, will bevel both edges of the material to 45 degrees, can be operated by a single employee, will accommodate for 10 and 11 gauge stainless steel, with widths of 6.813 inches and 5.25 inches respectively, implement rollers and side guides to reduce chatter and vibration, and have an easy setup and electrical interface. Testing has been conducted to determine the optimal feed rate and spindle speed to run the machine at. The testing consisted of setting up our cutting tool in a CNC machine and obtaining powerage and amperage readouts, observing surface finish and chip color. From this testing, we determined a cutting speed of 1,000 RPM and a feed rate of 15 inches per minute were optimal. This machine features a Gilman belt-driven spindle with a Kennametal 45-degree indexable end mill. The spindle can be adjusted for different width material with only 4 bolts. The material being beveled is held against the work surface with spring-loaded rollers and side guides. The spring-loaded rollers are used to apply constant downward force with the help of die springs. The material can be raised into the cutting head with the hand crank that controls the table's vertical position. The material is pulled across the cutting zone by the motorized feed roller. The 6-inch diameter feed roller will make 1 revolution every 1.5 minutes, with the use of a chain-driven geared motor. 2 turnbuckles are used to increase the clamping force on the material by the feed roller. This is the final design of our machine. The final cost of the full design is roughly $15,600. Majority of the cost is in the Gilman belt-driven spindles due to their high torque, low RPM specifications. Currently, the machine is completely assembled and the feeding process has been tested and meets all requirements. Testing of the cutting process is planned to take place prior to the delivery of the prototype to our industry supporter. Ward is planning to make future investments into the machine at a later date. These include a powder-coated paint job and a second Gilman spindle motor. Thank you for stopping in to see our design.